The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Example, Heisenberg uncertainty principle. An electron in the ground state of a hydrogen atom has a velocity of 2.2 times 10 to the power of 6 meters per second. If the uncertainty in the velocity of the electron is 10%, what is the uncertainty in the electron's position? And we're given Planck's constant and we are given the mass of an electron. Well, first let's begin with the Heisenberg uncertainty principle, the equation that we had right on the previous slide. Now, what is it that we're looking for? We need the uncertainty in the electron's position, right? So that's going to be delta x. Thus, if we isolate here for delta x, right? Let me just make that a little neater. If we isolate for delta x, right, we end up with the following equation, right? 4 pi mass velocity. Okay, great. Now we know Planck's constant and we know the mass, right? But we need the uncertainty here in the velocity, right? So let's go ahead and calculate that first, and then we'll have everything that we need. Now coming back here, we see that it's telling us that the uncertainty in the velocity of the electron is 10%. Thus, in order for us to find the value that we need, all we're going to need to do is we take the uncertainty percentage, right? The uncertainty percentage, and we multiply that by the actual velocity, and that's going to give us the uncertainty in the velocity of the electron. Thus, in doing so, if we uncertainty in the velocity of the electron, thus in doing so, that's just going to be, oh, let me make that a little neater here. That's just going to be 0.10 times 2.2 times 10 to the power of 6 meters per second as such. Yes, that's correct. And that's just going to be 0.2 times 10 to the power of 6 meters per second. Great. Now that we have all the values that we need to find the uncertainty in the electron's position, right, for our equation here, let's go ahead and fill in our values on the subsequent slide here. And we left off with our equation as follows, and here's the value that we found. Thus, if we go ahead and we just fill in our values here, right, as such, we know that beginning here with Planck's constant, that's just going to be 6.626 times 10 to the power of negative 34 kilograms. And again, that's just the value right there that we're using. Kilograms meters squared per second over, right, over, just get rid of the green there, over the over 4, and pi, the numerical value of pi that we can just use is 3.1416. Our mass of our electron is also given to us right here, right? That's just going to be 9.11 times 10 to the power of negative 30. Oh, make that just a little neater. 10 to the power of negative 31 kilograms. And the velocity value that we had was just 0.2 times 10 to the power of 6 meters per second, right? And there we are. That was our uncertainty in that. Now, once we go ahead and we equate this, we find that our value is going to be greater than 3.0 times 10 to the power of negative 10 meters. Or what is that going to be in picometers? That's going to be 300 picometers as such. Now, this value here may not seem that big to us, right? The uncertainty in the electron's position at 300 picometers may not seem that large initially, right? But this value is actually going to be quite massive relative to the actual hydrogen atom itself. Now, let me explain as to why. The actual hydrogen atom, right, if we look at the diameter of the hydrogen atom, that's what that stands for. That's what this symbol here, this is for the diameter of the hydrogen atom, that is actually 240 picometers. Now, if we were to contrast these two values, that the value here in the uncertainty in the electron's position at 300 picometers is actually massive compared to the diameter of the hydrogen atom, due to the fact that the diameter of the hydrogen atom itself is only 240 picometers, meaning that the uncertainty in the electron's position is actually larger than the atom itself. Okay, great. Let's now proceed to our next slide.